Hi, I'm Colin. We're going to use a procedure or algorithm called the sieve of Eratosthenes to find all the prime numbers between 1 and 100. A prime number is a whole number greater than 1, whose only positive divisors are itself and 1. For example, 6 is not prime because you can write 6 as 2 times 3. But 7 is prime since it is only divisible by itself and 1. Prime numbers are often regarded as the building blocks of all numbers and have fascinated people for thousands of years. Modern internet security is built on the fact that it is difficult to factorize very large numbers into the product of primes. Alright, let's now use the procedure to find our primes between 1 and 100. This will involve methodically crossing out all the numbers from the list which are not prime, just like letting them fall through the holes of a sieve. The numbers remaining in the list will then be prime numbers. This procedure was invented by the Greek mathematician Eratosthenes. This is why it's called the sieve of Eratosthenes. Okay, firstly, the number 1 by convention is not prime, so we cross it out. The next number 2 is prime, because it's divisible by itself and 1 only. So let's circle it. Now this means that all the multiples of 2 are not going to be prime, since being a multiple of 2 will precisely mean that it's divisible by 2. So let's cross out all of these multiples. Therefore 2 times 2 is gone, 2 times 3 is gone, 2 times 4 is gone, 2 times 5, and so on. Notice we've crossed out precisely all the even numbers. Alright, the next number 3 is prime, since it's certainly not divisible by 2. So let's circle it. All the multiples of 3 won't be prime, so we cross them all out. The next number that's not crossed out is 5, which is prime, since it's certainly not divisible by 2 or 3. So let's circle it. We then proceed to cross out all the multiples of 5. The next number that's not crossed out is 7, which is prime, since it's not divisible by 2, 3, or 5. So let's circle it. We also cross out all the multiples of 7. We can repeat this procedure until we get all the way up to 100. But let's stop for a second and think about the numbers that are not yet crossed out. Observe that 10 times 10 is 100. So the square of any number larger than 10 will therefore be larger than 100. Coming back to our list, if any of these numbers remaining larger than 10 is not prime, then it must be divisible by a number smaller than 10, a number between 2 and 9. But we've already crossed out all the multiples of these numbers, so that's not possible. This means all the remaining numbers are actually prime. Thus, we have used the sieve of Eratosthenes to find all the prime numbers between 1 and 100. They're all the numbers circled or boxed in blue. This algorithm is one of the most efficient ways to find all of the smaller primes and lends itself to being easily programmable into a computer. Alright, we hope you enjoyed that. See you next time.